All right, so we have a new topic today on percentiles. This is actually going to be a fair bit different than the other things that we've talked about before, but it's not a huge revolutionary brand new thing. It actually does have some connections, especially to median that we've talked about. Anyway, let's get started. So we're introducing a very new idea called percentiles that somewhat builds off the concept of median. We're going to look at some examples of percentile rankings today, as well as how to calculate percentile rankings. There's not going to be a lot to this today. I want to give you a lot of time to get some work time done, especially because yesterday's questions were so long. But anyway, let's get started here. So percentile ranking, right to it. What on earth is a percentile? Well, a percentile is a number that represents the percentage of items in an ordered list of data that rank lower than the given data item. Now, there's a few things we got to pick out here. First of all, the percentile is a number that represents a percentage of items in an ordered list of data, so in other words, from least to greatest, that actually rank lower than the given data item. Probably easier to understand this through an example. So for example, if your height is at what we call the 80th percentile, notice percentiles are always with like a kind of thing, like 80th, right? That's how percentiles are written. It's kind of a weird thing. But if your height's at the 80th percentile, what this means is you're as tall as or taller than 80% of people that you're being compared to. This picture I found below actually summarizes it pretty well. If this was you right here, the blue person right here, you would have a height at the 80th percentile because you are taller or as tall as 80% of the rest of the population. So that again is the 80th percentile. So another example, if your 100-meter sprint time, like in track and field, of course, 100-meter sprint time ranked at the 30th percentile, then that would then you would have sprinted as fast as or faster than 30% of the people you're being compared to. In other words, 50th percentile is like the middle of the road here. 30th percentile means you only outperformed 30% of the other people, so you were outranked by the other 70% of people in the whole ordered list, right? So a percentile is just more or less a way of comparing a certain data item or an individual, if they're part of the data set, to the rest of the data set as a whole as a type of percentage, right? Anyway, moving on. So I like these charts here. These are charts released from the CDC. I think that's the Center of Disease Control of all things. It's basically like a public health information organization in the United States. But they've actually graphed with these very bizarre graphs the percentile heights for boys and for girls as they develop from the age of 2 to the age of 20. So along our x-axis here, we have the age of 2 way down here and the age of 20 way over here. That's for boys, of course, and for girls, it's the same idea. Now, it might be hard to tell in the video unless you really turn the quality up, like if you turn it up to like 1080p or something like that, because it's going to be hard to read otherwise. Each of these lines on each of these graphs actually represent a different percentile. So this bold line that's in the middle on both graphs, that kind of just, snakes its way up the graph here, that line actually represents the 50th percentile height. And along our y-axis, at least on the right-hand side of both of these, are the heights in inches. If you prefer centimeters, though, it's also on the far left side, but I'll stick to inches for now. What this is saying is, let's say you're 17 years old and you're a boy. So if you're a boy who's 17 years old, you can follow this graph up and then figure out where you rank in terms of a percentile based on your height. So if, let's say, you were 17 years old and 70 inches tall, then the intersection between 17 years, following the line up, and 70 inches is this point right here. So if you're a 17-year-old boy who is 70 inches tall, that means you rank somewhere between 50th and 75th percentile. So maybe like 60-somethingth percentile for height. What that would mean is you're as tall as or taller than 60-ish% of the rest of the population of 17-year-old boys, because you're being compared in the same grouping, right? If you wanted to know what like 90th percentile was for a 17-year-old boy, you could just find the 90th percentile line. Well, that's this one right here. Looks like 90th percentile is about 72.5 inches-ish, so like just over 6 feet tall. That'd be 90th percentile. 5th percentile, on the other hand, so in other words, you're as tall as or taller than 5%, so much on the shorter end. It looks like you're just above 64 inches tall, which of course is 5'4", and that's how that goes. And the same goes for girls as well. So let's pick a different age for girls. Let's say, how about you're a 14-year-old girl and you were, let's just pick a height. Let's say you were 64 inches tall. So if you're 14 years old and you're 64 inches tall, that would put you, at the age of 14 at least, at just between, again, 50th and 75th percentile. So maybe like 60th percentile for height, right? Now these graphs, of course, you don't need to memorize these, you don't need to know them, but they are just a really cool application of percentile charts. If you want to find these graphs on your own, I think you can just literally Google like something like CDC growth chart, boys or girls, whatever you want to check the height of. The other thing that I also find very interesting about these graphs is you can actually see where like different genders here peak based on their height. Let's just look, for instance, at 50th percentile. Notice for girls, it starts to flatline about this point right here, so about the age of 15. So in other words, most girls are pretty much done growing at the age of 15. But if you look for boys, it doesn't start flatlining until about right here or so, maybe even a little earlier. Either way though, for boys, it doesn't start flatlining until the age of 17 or 18. This means that boys continue to grow until about the age of 17 or 18, at least on average. And of course, this is just an overall picture and not indicative of literally every single person, clearly. Anyway, moving on. Calculating percentage. How on earth do we calculate this? This is a math class after all. We got to calculate this. There's a bit of a weird formula for calculating percentile ranking, but the good news is it is on your formula sheet. That's that yellow formula sheet that I give out. It is on there. I think it's in the bottom right-hand corner somewhere. But anyway, it's PR equals B divided by N times 100. Well, that doesn't mean anything unless you know what those letters mean. Well, PR is actually one variable. That's your percentile ranking, okay? So your percentile ranking equals B, which is the number of values below, hence why it was called B, divided by N, which is the number of values in total. So the number of values that are below you divided by the total number of values, that includes yourself, and then times by 100, and that gives you percentile ranking. Now, unless it otherwise states, you should always round your percentile ranking to the nearest whole number. Like generally speaking, we don't want to say that someone's like the 52.4th percentile. We just round it to the nearest whole number. So we would say in that case, 52nd percentile, right? It just makes more sense that way. It's just a little bit easier, okay? But again, if it states otherwise, then just follow whatever the question asks. All right, let's do an example here. Let's say a class of students lined up in a row based on their height. Connor noticed that in his class of 30 students, that would be including him, 20 students were shorter than him. What is Connor's percentile ranking for height? Well, let's remember, percentile ranking is B over N times 100. And B is the number of values below your person, or your data item, I should really say to be more general. And N is your total number of data items in total, okay? So B, below in this case, we are looking at the students that are shorter. So there are 20 students shorter, so we can say B is 20 in this case. So PR equals 20 divided by number of students in total is 30, so divided by 30, and then times by 100. If you throw this in your calculator, you're going to find that PR equals 66.6 repeating. But remember, we don't like decimals in percentiles, so we just round to the nearest whole number. Our percentile ranking, therefore, is 67th percentile, right? So it's kind of, oops, I made a mistake there. Oops. Percentile, there you go. 67th percentile. So percentile is kind of weird in that it's not actually given as a percent. Like the answer is not 67%. The answer is 67th percentile, okay? But what a percentile represents, of course, is that Connor is as tall as or taller than 67% of his class, okay? Now be careful with these questions, of course. This one was nice because it told us that 20 students were shorter, so it explicitly gave us the below. But if this question instead said that 9 are taller, you wouldn't use 9 for your B value, right? You'd actually have to take 9 and subtract that away from 30, right? And that would give you 21, but then you got to include that Connor's one of those 21, so you'd have to remove him and then drop it down and say, okay, 20 are absolutely shorter. The B value needs to represent those that are actually below your individual in the list. It does not include your person in the list, so make that very clear. All right, so another example here. The following were bowling scores in a tournament. So if you look at this list here, you can see there's 8 different people in the list and all their names as well as their bowling scores. So the question is asking, what is Amy's percentile ranking? Okay, so we want to figure out what Amy's percentile is here. Well, let's remember, PR equals B over N times 100. B are the number that actually were below, in this case, Amy, in the bowling tournament, right? N is the number in total. N is probably easier to start with here. If we look at this, this table, we can see that there are 8 different people who bowled in this tournament. So I can say right off the bat that N is 8. But let's figure out B, and B is going to take a little bit of time. We've got to be really careful to make sure we get B correctly. Notice Amy, her score was 204. We got to figure out how many of these scores were below that. So I'm just going to go one person at a time and figure out how many were below that. This would have been a lot easier if this was an ordered list, but you can tell just by looking at it really quickly that this is not an ordered list. It bounces all over the place. If you want to order it yourself, that's fine, but you don't actually have to. You just can also check to see which ones are below. Anyway, I'm going to stop rambling on that. Let's check each point to see which ones are lower than 204. Well, Beth certainly is, so there's one. Todd also is, that's another one. Cam, however, he's not below 204, so I won't include him. Mandy, yeah, she's below 204. Dawn, no. Stu, yeah, that's below 204. And Becky, no, that's above 204. So you can see based on the check marks I put in here, there's 4 that are below. So I can say B equals 4, right? Now let's just throw that into the equation. PR, your percentile ranking, is B, which is 4 divided by 8 times 100. Throw this in your calculator and you're going to find that PR equals the 50th percentile. Whoa, what on earth happened there? 50th cent? No, 50th percentile. There you go. 50th percentile is your percentile ranking. Whew. So in other words, she did as good as or better than 50% of the people here, not including herself, of course. Now, there's an interesting thing about 50th percentile, actually. 50th percentile, believe it or not, is actually close to your median. It's a pretty good approximation for it. So 50th percentile, of course, means that 50% of the population is below that point. Logically, that means that 50% is also above that point. Generally speaking, of course, with that last example, because there was a relatively small number of data points, only 8 in total, didn't quite work that way. But usually, especially on a large data set, it works pretty well. Now, I want to remind you that the median is the middle data point. So if we looked at this chart, I literally just found this chart by Googling it really quick. It's the height of 55 students. You can tell that the median, the middle height, is probably somewhere in this range here. Half the people are below, half the people are above. Well, if half the people are below and half the people are above, then your median is pretty close to, full equal sign, I'll just like a squiggly equal sign, pretty close to your 50th percentile. Kind of a cool observation that actually makes it pretty useful in one way. All right, I think this is the last question. For example, when Bert finished in the national long jump competition, he was told that his performance was at the 75th percentile. So that's pretty good, right? 75th percentile means you were above 75% of everyone else. He was also told that 4,500 people entered the competition in total. How many people didn't jump as far as Bert? This question is really just asking how many people were below Bert in our list. Well, let's use our formula. PR equals B over N times by 100. Let's ask ourselves what we know here. Well, we know our percentile ranking is 75, okay? We also know that the number of people who entered the competition in total are 4,500. So let's just plug those into this equation. We know 75 equals B, that's what we're trying to find, the number of people below, divided by 4,500 times by 100. Now, to get a variable all by itself, that's just more or less going to require us to work backwards, okay? So what I'm trying to say with this, what I'm trying to spit out here, is we want B. We want to figure out how many people were below Bert. So let's just get B all by itself by doing everything else that's happening to B just in reverse. So instead of this times by 100, let's get rid of that by dividing by 100 on both sides. So if I divide by 100 on both sides, 75 divided by 100 gives me 0.75 equals B over 4,500. Well, let's now think about how we can get rid of 4,500. What's the opposite of dividing? Well, the opposite of dividing is timesing. So let's now times both sides by 4,500. This is actually going to give us B equals, and I calculated it before I started here, 3,375. So the number of people that didn't jump as far as Bert was 3,375 out of that total of 4,500. So, you know, he beat quite a lot of people at that long jump competition. He didn't get first place by any means. He wasn't at like the top percentile, but he did pretty darn good, I'd say. Now, how many people jumped further than Bert? Here's an interesting one. If this is the number of people who jumped not as far as Bert, then the opposite of that is going to be the number of people who jumped further than Bert. Well, we know 4,500 people jumped in total. So if we say 4,500 and find the difference of that between this 3,375, that gives us 1,125 people. But let's be really careful here. Bert is one of these 4,500 people. We can't say that Bert jumped further than Bert. That doesn't make any sense at all. He jumped just as far as he did, right? That doesn't make any sense, right? So this 1,125 actually includes Bert. So I'll even write that. That includes Bert. So that doesn't make any sense. We don't want to include Bert in this. Remember, in our B value, the B value never includes the person that you're looking at, right? So that one we didn't have to worry about. But this time it's the opposite of the B value, so it does include Bert. Hopefully what you're seeing is to not include Bert, we just have to take one away from this. So in other words, 1,124 people would be the answer, right? So that's the number of people that jumped further than Bert did. Anyway, moving on here for practice, I want you to do page 133 to 139, do all the questions that are in that range. We're going to go over any questions you might have from this during tomorrow, that's Wednesday's Zoom meeting, okay? That finishes with this chapter off. We're actually done the statistics chapter. That actually went pretty quick. So after completing these questions and checking your answers, you may start the Chapter 3 assignment. Chapter 3 assignment, I did give you the booklet in printed form, but in case you've misplaced it, it is also found on the Google Classroom page. This assignment is now due on Wednesday, April 22nd at the absolute latest. Submit it when you are done. As soon as you're done, we can just collect it there. I'll mark it as quick as I can, and then we'll go from there. All right. After that assignment's done, any corrections we make from it, then we'll have our chapter test. That's how this is going to work. Anyway, best of luck. Again, if you have any questions, send me an email, post a message on Google Classroom, reach out to me one way or another. Anyway, I'll talk to you on the Zoom. Best of luck.